Hello everyone, question number 44 on HC Verma. A very interesting problem, and if you have done this problem, you should be able to do pretty much any projectile motion problem. But this problem also has a few problems. It's not presented that well by SC Verma. But let's look at the problem. Your approach is more important. What we have is a ball is thrown with a speed of 35 meter per second, and this ball is thrown at an angle of 53 degrees. So obviously it takes a parabolic path like this, and what we have here is a gallery, it's a cricket stadium, so it is something like that. And what we need to find out, and these stairs, I'll make it larger, have 1 meter height and 1 meter width, then 1 meter like this. These are the stands. We need to find out, and this distance is given as 110 meter. So it's going to strike one of these stands in this gallery, and we need to find out which gallery it hits. So the first thing we need to do is resolve this velocity in horizontal and vertical components. One thing you must remember in all physics problem is the values of 53-degree angle. Anyway, so this is 53-degree angle. Anytime you are given angles like 53 degree or 37 degree, they have a very specific value. For 53 degree angle, it's 4, this is 3, this is 5. The sides of a golden triangle, which means that cos 53 degree will be equal to 4 by 5 and sin 53 will be equal to 3, this is the reverse, 3 by 5 and sin 53 degree will be 4 by 5. If you reverse this 3 and 4, and you need to keep in mind, compare its value of sin 53 or sin 37 with respect to sin 30 degree. Anyway, I will not go. I have another video on this, how to make sure you are able to memorize it. Now this velocity has this component, horizontal component, which will be 35 cos 53 degree. I write it 35 cos 53 degree. And cos 53 degree is 3 by 5. This is 7 into 3 is 21 meter per second. This is the speed with which it moves in the x-axis direction. And this horizontal velocity does not change because there is no force acting against this movement or helping this movement to accelerate it. Now the vertical component of this velocity is 35 sin 53 degree or 35 into sin 53 is 4 by 5, 5 into 7, 7 into 4, this is 28 meter per second. So 28 meter per second is the velocity with which it starts vertically, but the action of acceleration, the force of acceleration keeps it reducing along its way. This is how the motion of this becomes 0 here. The vertical velocity becomes 0 here. Now we got two equations from these. In the horizontal, if there is a displacement x in time t, then this x horizontal displacement is given by this horizontal velocity u cos theta multiplied by t, 35 cos 53 degree multiplied by the time t, or we can also write it as x is equal to 21t. This is our equation number 1. So this is the equation which represents the displacement in the x direction with time. In the same way, we can write an equation in the y direction using the formula S equal to ut plus half a t square. That will give y is equal to u sine theta, which is 35 sine 53 degree or 28 meter per second. This is our vertical velocity. I will directly write it as 28t minus half into g multiplied by t square. At this point, when I already solved it, I use two different values of g. One is 9.8 meter per second square, another is 10 meter per second square. When I solved this whole thing, I got wrong answer. And the reason was that the g value that I took was 10 meter per second. And see, we are talking about 110 meter, whether this 3 steps or 4 steps. So even a small change in the g value significantly affects what the answer you get here. So that is the first problem with this problem, which means that he should have specifically mentioned that take the value of g as 9.8 meter per second square. If I get a chance, I will show you a graph on a computer simulation how the graphs look like when you take the value of g as 9.8 versus 10. So let's solve this problem. I will write y is equal to 28t minus half into 9.8 into t square. This is our equation number 2. Now substitute this value of x, so t from here to y here. What we are trying to do is we are trying to get a equation of the trajectory in x and y, because that is the trajectory. When we get that trajectory, we need to find the equation of that trajectory with that stair. So substitute the value of t from here to here, we get y equal to 28 into t is x upon 21 minus this is 4.9 multiplied by t square is t square by 21. So one of the hints you get is 21 into 21. One of the hints you get is that this is divided by 7, 4, this is 3. That this can be divided by 7. 7 into 3, 21, 7 into 3, 21. If instead of 98, if 9.8, if you take 10, then this will be a even more complicated quantity. So we write 7, this 0.7 becomes 3 here, 0.1 becomes 3 here. So the whole equation becomes y square is equal to 4 by 3x minus 3 into 3 is 9 and 0.1 can go down, becomes t, this is x square. X square divided by 90. This is y. And if you can rearrange this equation, it becomes 90 y is equal to 120x minus x square. This is our equation of the trajectory of the motion. I have not used any predefined equation. You could use that if you are able to memorize it. I don't memorize, I don't know, so I have used it to directly derive it on the spot. It's simpler. The term involves sec and tan theta, and if you have it in your memory, you can write it directly. Both the options are okay. The problem with the equation form, directly memorizing it, you are not doing this problem many often. These problems come only 2 or 3 times in the whole exercise, and you memorize only those formula that you use again and again and again. You don't memorize it and then do the problem. You solve the problems, and the process of that solving the problem, you memorize this formula. So let's move on. How do we solve the intersection point with these stairs? So one way to do is, and it's actually will be a problem will be very good for a software, computer software, is to find the intersection of this equation with this all these equations 1, 2, 3, 4 and so on and so forth, and find out which one of these you get a solution with. And for the one that you get a solution is the one that it hits. But instead, to get a close by idea, what we can do is we write down a straight line like this. So essentially what we are doing is we are trying to first find out, as a first approximation, where does this parabola hit a line which is at 45 degrees from here and which is right at the base of these stairs. The first stair starting at 110 meters. Now this straight line has equation of the form y is equal to mx plus c, and we know that it's 45 degree. The reason why it's 45 degree is because this is 1 and this is 1. So this stairs has a size of 1 as well as height of 1. So that's why this angle has to be 1 by 1. So m has to be 1 or it has to be 45 degree. The equation has the form y is equal to x plus c. And you can find c by the condition that at x is equal to 110, y is 0. Y is 0 at x is equal to 110. That means c is equal to minus 110. The equation is y is equal to x minus 110. Now we have this equation. We can substitute the equation of this line in this equation. So you get 90 into y. Instead of y, I write and x minus 110 is equal to 120x minus x square. That will give you x square minus 30x, x square minus 30x minus 9900 is equal to 0. So this equation we can solve and get the value of x. X is equal to minus b plus minus under root of b square is 900 minus 4ac divided by 2a. And if you solve this one, you will get some answer like 115.2 or 115.2 or something like that. So let's trace this down. What does x equal to 112 minus 2 means? I am giving a bigger, so the projectile motion, that projectile motion is coming from like here. I'll make a bigger picture, and this is 110, and this one, if the value of this x would have been somewhere between 110 to 111, there was a good chance that the ball would have hit the first one, the first of these things. If the value were between 111 and 112, there was a chance that, good chance that it would have hit here, and so on and so forth. Now our value of x is in between 116 to 115. So I will write, if the x is lying between 111 to 110, it is in first stair. So depending upon this number, it is either first or second or third. So in our case, it's going to be, it's possibly the sixth stair, 1, 2, 3, 4, 5 and 6th stair, because it is hitting at 112, 113, 14, 15. So this is trying to hit it somewhere like this, and that's why this is 115, this is 116. So it's possibly hitting this stair. The problem does not end here. It's possible that it could hit at x is equal to 115.2 or 115.6, whatever the answer is, by coming from here and going into this. Or it could also come in this this line by going through this. That means we need to find out whether it's hitting this line or it is hitting this line. And depending upon that, the answer could be either 5 or 6. If it hits here, then the person sitting here, the guy sitting here, will be hit. And we should take it as the 5th stand. Now the equation of this line, how do we find that, whether it hits through this or this? To do that, I rubbed this equation, but whatever some equation was y is equal to something x minus x square. In that equation, we need to find out its intersection with this line. X is equal to 115. Substitute the value of x and find the value of y. And if y, by after substituting, you will get some value of y. If that y lies between here and here, which is 1, 2, 3, 4, 5, 6 and 5, then the ball is coming through this. If not, then you need to check the other condition. We need to check whether this projectile hit this line. And for that, this line has equation 1, 2, 3, 4, 5, 6. Y is equal to 6. Substitute this value of y here and find the value of x. And if that x lies between 116, 215, and that means the ball has hit this particular horizontal bench and not the vertical bench. When you will solve that, you will find that the ball is hitting this one and not this one. In this one, you will get a value of y. In this case, you will get a value of y which will be higher than 6. That will prove that the ball is trying to actually hit this bench. That completes the solution. Very good problem, but in this thing, there are few problems with the problem. One is you need to take the value of g is equal to 9.8 meter per second square. If you take g equal to 10 meter per second square, you will get a wrong answer. And there is another ambiguity in this problem that you should keep in mind. That ambiguity has to do with this is the projectile motion. It is said that the first stand is at 110 meter. Now, you may argue that where does the first stand exactly start? Is it like this? Or you can also say that the first stand may start like this. 1 meter here and 1 meter here. Because the argument could be that the person sitting here needs some leg space. So this is a part of that first stand. But it looks like this should have been clearly shown by making a diagram like this. It looks like the solution favors this arrangement where the stand starts exactly from this point with 1 meter and a 1 meter. That means you do not have a leg space. The leg is on the ground of this thing. So that is another ambiguity in this problem, or the problem with the problem. But the concept itself is good. The concept of the problem is good, that you need to find out the trajectory of this, and you don't have to memorize the formula, and then you need to find out its intersection with some other line and then find their coordinates. So I hope this helps you. Thanks for taking a look.